Hi, everyone, and welcome to episode 860 of People Behind the Science. I'm your host, Dr. Marie McNeely, and I'm looking forward to resharing my interview with Dr. Ana Luisa Trejos today. Listeners, Ana Luisa works in the field of mechatronic systems engineering, which combines mechanical, electrical, computer, and software engineering to develop smart machines that can perceive what's happening in the environment and react intelligently. She's designing wearable mechatronic technologies to help people recover from mobility problems. And her goal is to make these technology solutions more comfortable for users and also to restore mobility and quality of life for people with upper body movement impairments. And in our conversation, Ana Luisa shares some great insights and stories from her life and research. So listeners, get ready to meet another one of our remarkable people behind the science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to People Behind the Science. Today, I am thrilled to be speaking with our guest scientist, Dr. Ana Luisa Trejos. So, Ana Luisa, thank you so much for joining us on the show today. How are you?
I'm doing great. Thank you for having me.
Well, we are so excited to have you with us and to be learning more about you and the work that you do. But let me first start by telling our listeners a little bit more about your current position and how you got there. So listeners, Ana Luisa is Associate Professor of Electrical and Computer Engineering, as well as Biomedical Engineering at Western University in Canada. She is also an Associate Scientist at Lawson Health Research Institute. Ana Luisa was awarded her bachelor's degree in Mechanical Engineering from the University of Costa Rica and her master's in Mechanical Engineering from the University of British Columbia. She worked as an applications engineer for Progressive Moulded Products in Ontario from 2000 to 2003. She then joined the team at Canadian Surgical Technologies and Advanced Robotics at Western University. Ana Luisa later attended graduate school at Western University, where she was awarded her Ph.D. degree in Electrical and Computer Engineering in 2012. Ana Luisa has been awarded the IEEE London Section Outstanding Women in Engineering Award, as well as the For Inspiration and Recognition of Science and Technology, or FIRST, Canada District Volunteer Appreciation Award. And in our conversation today, Ana Luisa is going to share more about both her life and her research. So, Ana Luisa, I'd love to hear more about you as a person, in addition to you as a scientist and engineer. So, can you start by telling us what you like to do in your free time?
Absolutely. So, apart from hanging out with my family, which is probably my favorite thing to do, I enjoy reading, building jigsaw puzzles, and exercising in general. In the summer, I like hiking and swimming. I played ultimate frisbee for many years, but I had to retire due to injuries. But I still like running and I love dancing. And believe it or not, I enjoy doing renovation projects in my house. If only I had more time for that.
So what is one of the latest projects?
I'm working on a bathroom within our bedroom area that had a little bit of water damage. So it basically had to be gutted and started from zero. So it's been a long project, but one that's been very rewarding at the same time.
It's daunting, but then you can make it exactly how you want it, right?
Exactly. Yes.
Wonderful. Well, you mentioned one of your hobbies is reading, and we love talking about books on the show. So do you have any book recommendations, something you've really enjoyed that you think me and our listeners should read?
It's funny because my favorite thing to read has nothing to do with academia. I love reading crime books. And I think it has to do with the problem-solving aspect of trying to solve a crime. And my favorite author of crime books is an Irish author called Tana French. And my favorite book of those is called The Secret Place. And I think what I really like about it is that she's really good at describing people's reactions when they're being questioned about different things and the little nuances of their emotions and how those are interpreted by the experts as to whether they're lying or not. I find that really entertaining for some reason.
Well, thank you for sharing one of these book recommendations. We will put The Secret Place on our website for our listeners to find there. And I'd love to chat a little bit about your science as well. So how do you describe your work, Ana Luisa, to people who maybe aren't familiar with your field?
I work in a field that is called Mechatronic Systems Engineering, and that's a big word, but it's the combination of mechanical, electrical, computer, and software engineering, where they all come together. So when we think about a mechatronic system, it's like a robot. It's a smart machine, something that perceives what's happening in the environment and reacts intelligently. So as a professor, I have an opportunity to dedicate a significant amount of time to doing research in new areas. And what I have chosen to do is designing wearable technologies that are mechatronic technologies that can help people with mobility problems. So, for example, helping a person recover from a sprain or a fall, or helping people that have movement disorders such as Parkinson's disease. So the issue with the current systems is that they're too heavy. They're just very cumbersome to be wearing all the time. And so they get in the way of natural motion. And then my work focuses on developing these types of devices, but more like clothing. So smart wearable garments like shirts or sleeves that support upper body mobility. So I work both on the hardware side. So how do we integrate the various components within the clothing? And then the software that can intelligently respond to whoever is using the technology. The ultimate goal of this is then to be able to restore mobility and improve the quality of life for those who suffer daily from some kind of upper body disability.
Well, Ana Luisa, your research is really fascinating, and I think it's easy for me and our listeners to see the potential impacts of this work. And this in and of itself can be very motivating for scientists. But we love to talk about quotes and sayings and forces that keep you going when times get tough, because I think all of us can use a little extra motivation and inspiration. So do you have a favorite quote or a saying?
Yes, I do. I saw a quote from Professor Charles Gordon. He was the head of the Department of Sociology and Anthropology at Carleton. And he said, "We are all smart. Distinguish yourself by being kind." And this is, of course, especially true in academia. There's so much competition. There's such a need to be critical, to find the flaws in things, that the environment can become very negative very quickly. So I think it's always important to consider how others feel and put those feelings first. Being gentle when you're giving criticism, being welcoming of people's requests, even if you're going to have to say no, but being kind about it. And then, of course, ensuring that positive feedback is always provided. I think those are very critical things to have in our field.
Absolutely. I think this is phenomenal advice. And for you specifically, when you employ this, do you find that people are kinder in return?
Yes, it pays off to be kind. When you try to be a little bit less kind because you feel that you have to, it just never pays off. It's not a good thing.
It backfires. Mm-hmm.
Exactly.
So this is a phenomenal quote to share with me and our listeners. And I'd love to chat next about some of the people who might have inspired you or motivated you or helped you get to where you are today. So Ana Luisa, are there particular mentors or role models that you can really point to that had an impact?
Yes, I can. But I do have to say that unfortunately, I seem to go through life learning what to do from those around me, but it's like learning what not to do more than learning what to do. But it's surprisingly a very good way to learn as long as you become critical and analytical about it, right? So if somebody does something and you're like, that wasn't the right thing to do, then you can learn to do something differently next time. But I have had some really amazing people in my life. And I think throughout my life, my most important role model has probably been my dad, who's not only an engineer himself, but just a genuinely good person. So that has been a very good example to follow. He does live in Costa Rica. So right now in Canada, I have a really great peer group with 3 other professors who have become the people who I look up to for all academic and sometimes even personal issues. So these are Sarah Gallagher, Amanda Mering, and Beth Gillies, are 3 really amazing, successful women who inspire me every day to do better.
That is phenomenal. It sounds like you've got some great people there as a support network for you to keep you going in the work that you do. And I'm fascinated by, you mentioned your dad is an engineer. What kind of work does he do?
My dad is retired now, but he did electrical engineering for his undergrad, and then he completed a second degree in mechanical engineering, which was sort of new at the time to do 2 degrees. He actually worked as a professor a part of his time, but most of his time was dedicated to the design of electromechanical drawings for construction purposes. So he used to do inspection. I used to go with him. I have to wear like a little hard hat when we went into the construction sites, but he did a lot of work and did some really cool projects with that.
Oh, that is amazing. I can picture little Ana Luisa on these construction sites with her dad. So was this what first sparked your interest in engineering?
Yes, it was actually. I used to see him doing engineering work. I wasn't sure what engineering entailed. And I used to be really good at math and science. And I thought that I wanted to go into either studying math or studying physics. I really liked astrophysics. So he knew this and he said, well, if you like math and science, then you may want to consider engineering. And as soon as he said it, I was like, yeah, that's it. That's the right path for me.
Perfect. So then you went off to undergraduate there in Costa Rica. Can you tell us about your experience, and were you able to get some hands-on research experience?
Not during my undergrad. The University of Costa Rica didn't really have a research program at the time, but I was actually the only woman in my graduating class. I did have some women classmates in some of the courses that I was taking, but within the mechanical engineering group that we had, I was the only woman.
Oh, wow.
And that had its pros and cons, mostly pros, I have to say, because my male classmates were all very protective and very friendly with me to make sure that I was not taken advantage of in any way, right? Like they were almost like big brothers in a way.
Aww.
So that was actually really great. But no, it wasn't until my master's that I got into the research field. So after my undergraduate degree in Costa Rica, I went to UBC and did my master's also in mechanical engineering. That's when I got into the field of medical robotics.
Certainly. And then when you finish your master's degree, a lot of people have this idea of what the path is to become an academic professor, but you took a slightly different path. So can you talk about what that experience was like and maybe what led you to that decision?
When I finished my master's, I wasn't very happy with what research was. I was not thrilled about the entire master's experience. So I wanted to try out working in industry. And I went to a career fair in Toronto during that time and got to meet some really great people who were very keen to hire me. This person was Dave Yeaman, and he became my boss at Progressive Moulded Products in a city called Concord, which is just north of Toronto. And that was part of the automotive industry. So I worked there for just over 2 years and got to learn a lot about time management, budget control, all those things that you don't necessarily learn to do in academia.
Certainly. Then what helped you decide that you wanted to go back to academia?
It wasn't an easy decision. And in fact, when I first got back to academia, I didn't want to be back in it. I moved to London at that time because my husband had gotten a position at Western. When I say London, I mean London, Ontario, not London, England. Mm-hmm. So I came here and I started looking for jobs, and there was a really great opportunity at Canadian Surgical Technologies and Advanced Robotics. So that was part of the university, but associated with the university hospital as well. It was a research center where the people would develop medical robotics or develop technologies associated with medical robotics with the goal of reducing the invasiveness of surgery so that people would recover faster. This was a very clear continuation of what my master's project had been. So I got the position as a research engineer, and I basically hit the ground running. It was like that period in industry had never happened. And suddenly I enjoyed doing research and I enjoyed being in academia again. So I did that for about 4 years. And then my supervisor insisted that I needed to do a Ph.D. so that I could become my own independent researcher. And funny, I did not want to do it.
Really?
It took him at least a year to convince me. And I said, okay, I'll do it, which is sort of the contrary to what most people go through, right? They're desperate to do a PhD and they're searching everywhere and they can't find a position. And for me, it was the opposite. I just wanted to continue doing the research and doing the engineering work. But once I started, it was like the right decision for me. I started becoming also more independent. I wanted to do my research independently. So it was definitely the right thing for me to do then. So once I finished my PhD, then there was a position available at Western and I was able to start as a professor.
Phenomenal. And you are doing some amazing research projects there at Western University. So is there one in particular that you have in the works right now, Ana Luisa, that you want to tell me and our listeners about in more detail?
Absolutely. So over the past few years, I've been really fortunate to be leading an amazing group of trainees and collaborators on the development of a wearable glove for suppressing hand tremor in people that live with Parkinson's disease. So you know that one of the main issues with Parkinson's is that there's tremor in the hands. Well, it's tremor in the whole body, but the tremor in the hands really prevents them from being able to complete activities of daily living. So something as simple as drinking or eating can be very limiting for them. So another professor in mechanical engineering, Michael Naish, and we started working with Dr. Mary Jenkins, a movement disorder specialist. And we hired Yue Zhou, who has been an amazing student. He did his master's, his PhD, and is now completing his postdoc with us, all on the development of these gloves. So we've been working on the development of the software. So how do we measure the motion? How do we distinguish the tremor motion from the voluntary motion and separate it so that we're only suppressing the tremor motion and not suppressing the voluntary motion. We've done the development of the way that we want to sense it, the way that we want to process the data, so we can do the separation of the signals. And then how do we use that information to control our motors so that we are applying forces directly onto the wrist and the fingers so that we're suppressing that tremor. We're also doing a lot of research into the integration of the components into a wearable device so that it is comfortable to wear. It's customized to each person. So it considers not only the size and the shape of a person's hand, but also the characteristics of their particular tremor. And this has been a really great project. There's a lot of people that have been very interested in having this, which highlights how important it is to have this kind of technology out there helping people.
Certainly. And I know with Parkinson's tremor in particular, it happens within a certain frequency range, but the amplitude and some of the other characteristics definitely differ between individuals. So was it difficult to pinpoint how to really personalize that across people?
Yes, and mostly because they change a lot over time. So some people will have just the resting tremor. Some people will have postural tremor, like when they're holding a book. Some people will have action tremor, which is when they're moving. Mm-hmm. So the transition between resting and moving can be very different. How their tremor changes from one type of motion to the other can be very different in different people. So a lot of the research we're doing now is try to identify that onset of tremor. So when is it about to start? And what are the characteristics that it's about to have? Because we need to know that little tiny time step ahead of time so that then our motors can activate in time and that there's no delay. So I think that's the difficulty in getting this off the ground fully. It's being able to be ahead of time and being able to predict ahead of time when the tremor is about to start.
Absolutely. So to help me and our listeners visualize this, what does this glove look like?
So imagine a regular cloth glove, but it has rings around the fingers. And then it has a hard pad on the back of the hand and on the palm of the hand. And then on the wrist, there's where the motors are located. So we have 3 little motors and some other electrical components. We also have sensors that are attached to the fingers, which are just like little electric boards that contain all of the sensors and the components needed to process the sensor data. And there's cables that then run from the motors along the dorsal side and the palm of the hand and attached to the rings in the fingers. So when the motion starts, the motors then detect the voluntary motion and allow the cables to move such that they're allowing the voluntary motion. So if a person has action tremor, they're not completely stopped by the movement of the motors trying to suppress the tremor.
So this is phenomenal. What is the next step then for this research once you kind of get this personalization part completed?
The next step is to try to make them a little bit less cumbersome. So we're using electric motors right now, which make them still too heavy. It doesn't matter how small the motor itself is. We need one motor for every degree of motion of every joint in the hand. So you can imagine that this can be very heavy if we have a lot of motors. So we're working on the design of new type of actuation technology. Actuators are type of motors, but they're not the standard cylindrical thing that you would imagine with a motor. These actuators are called twisted coiled actuators, and they're more like a cord. So if you think of the cord that goes around a jacket, maybe, that it's like a thin cord, but we make them very, very thin, and they're made from nylon that has been covered with silver coating so that they're conductive. And then when we put current through them, it contracts. So we can get quite a bit of deformation and quite a bit of force with a flexible cord. The difficulty there is that we're trying to work ways for cooling them better so that it's easy to contract them because we just put current through it and it heats it up and it contracts. But then to cool them, we have to sort of let it be, or we have to do some kind of active cooling like using air or some kind of liquid. So we're working on the characterization of the actuators. So what is the best environment in order to cool them? And then, of course, the hardware associated with it. That's a new area that we're exploring, and integrating the two together would be very important for the wearable gloves to be very unobtrusive and people can truly wear them all the time.
Well, this is a really exciting project. I could ask you questions all day, but I'm curious about some of these opportunities and challenges that you mentioned with this specific project. But I think in general, as a scientist, as an engineer, there are so many challenges that you face and have to overcome, both within your research and just in the career path and in life in general. So when you think back over your experiences, Ana Luisa, is there a particular failure that was just really distressing or a particular challenge that was just really tough for you to work through that you can share with me and our listeners and talk about that experience and how you got through it?
So I think my entire master's was a bit of a failure for me personally. I was new to Canada, so there was a little bit of a culture shock there. I was used to very honest feedback. If I wasn't doing something right, it was very clear to me. So coming to the Canadian culture, well, everything is so polite. People would say, oh, you may want to do this, or you may want to try that. And I actually thought that they thought that I should try it, that it wasn't an order. But with the Canadian culture, it was an order, right? When somebody said you may want to try this, it was like, you have to try this,
that
right?
means do this, right?
So that was one of the things that I found very difficult. And I was also very new to research. I really had no idea what research was. I thought that a master's was like a continuation of an undergraduate degree where I was going to take some courses and there were going to be some assignments and then I would just continue learning. Obviously, it's not. And my supervisors, rightly so, probably had no idea that a person could not know what research was. But it didn't dawn on me that it was something different until I was very much into my master's. And then I was very confused about what I was really supposed to do. And it wasn't that my supervisors didn't try. I honestly don't blame them for it. But maybe they didn't know how to guide me. And I think that that should have been handled a little better. But I had really great support of my husband, who was my boyfriend at the time, and a really good friend of mine, Simon DeMaio, who was a lab mate. They were very supportive, and they were the ones that mentored me and guided me to be able to successfully complete my master's. The way that I got through it is that I basically set an end date when I was going to leave Vancouver. I did it at UBC. And I bought my ticket and I told my supervisors, I either defend or I'm going to leave because I can't do this anymore.
Oh, wow.
And they got their act together in a way. They finished reading my thesis, which had been submitted to them. I know I sort of put them on the spot a little bit there. I think I'd be very upset if a student did that to me. But I successfully defended and I was able to leave. At the time, I had really low self-esteem when I left. I still see it as a major failure. Even though I passed and graduated, but I learned a lot from it about what to do and what not to do, and also who I was as a person or who I am as a person. And when I moved to Toronto, that's part of the reasons why I wanted to go into industry. When I started working with Davey Amon, he was almost the opposite in personality from my supervisors. He was very hands-on and he thought very, very highly of me, even though I don't know why, because he hadn't had an opportunity to see what I could do, or I hadn't demonstrated any of my skills. But he really lifted my spirits. And then, of course, I was then able to reach my potential. I was happy again. I was learning again. But the experience changed significantly because of the people that I was working with.
Certainly. And I think setting those deadlines is a good motivator. It's a good way to make things happen, because I think master's degrees or PhDs, sometimes they just feel like they go on and on and on. And it's difficult to decide where the end point is. So how did you make that determination of where that end date is going to be?
I think that was part of having my husband on the phone with me. He was in Toronto at the time. He said, you just have to buy your ticket. He was the one that suggested. And I'm like, you're absolutely right. And I said, okay, well, I've already submitted my thesis. I just need the feedback. And I sort of worked it backwards. And I said, okay, I think I can leave by this date. And I bought the tickets.
That's very brave of you. I admire that.
And yeah, they were very upset. My supervisors were definitely very upset when I did that. But I think it was sort of like a fight or flight response. It was either that or I was not going to be finishing. It's sort of funny because there wasn't anything really terrible about it. It was just the fact that I felt like a failure. I didn't know what I was doing. I had felt that it had been a struggle all along. Of course, I had done enough to get my master's degree. That wasn't the issue, but it was just how everything had happened that I was just very upset with the whole thing.
Certainly. And I appreciate you talking really candidly about what you went through in your master's program, because I think that's something that a lot of our listeners are going to be able to relate to, just having a difficult time in graduate school. But we don't want to dwell on the challenges. Ana Luisa, I'd love to talk about some of your successes as well. And you've had some fantastic ones. So do you have a favorite success story you'd like to share?
Yes, and you're right that we don't really take enough time to celebrate the little wins, especially when they come around a lot of rejections. But in the research field, our successes come in the form of grants being awarded and papers being accepted and students graduating. And there's such a relief when they're successful that it's difficult to celebrate them appropriately. But other than that, I think the success that I really want to tell you about is related to my work in outreach and encouraging girls and young women to consider engineering as a career. So I often do a lot of outreach events. I go to different universities or events here at the university where I talk to young girls about what engineering is, what the different disciplines are, and the type of jobs that you can get as an engineer. So there's a big misconception about what engineering is. And a lot of people imagine a person with a hard hat, sort of what I thought engineering was. A hard hat in a construction site, right? Which is not really a good representation of all of the variety of jobs you can get as engineers. So the goal of my outreach work has always been to inform the community about what engineering really is, how an engineering degree prepares you or provides a starting point for almost any job you could want in the future. And basically, you're opening up all the doors by having a degree in engineering. And it's very frustrating because I dedicate a lot of hours to it. I've done it for many years now. And when I look at the numbers of women choosing to study engineering, it's just barely going up, right? So it's a little bit frustrating at times. But the recent success that I got was having recognized a little bit for my outreach work. So last year, I received 2 different awards, one from the Institute of Electrical and Electronic Engineering, or the IEEE. The London section, I received the Outstanding Women in Engineering Award. And that same year, I got the first Canada District Volunteer Appreciation Award. So the first Robotics holds all these different events. There's the first Lego League competition for kids in elementary school. There's the first robotics competition for kids in high school. There's various others. And I've been doing quite a bit of volunteer work with both the first Lego League and the first Robotics. So I was very surprised when I got the District Volunteer Appreciation Award last year. So all of that is a little success in the sense that at least I'm being recognized for the work that I do. And I think that eventually the numbers will go up. And ultimately, that's not the goal. The goal is to just make sure that the girls know that engineering is a path that they can take. But I'd like to see that reflected in increased numbers of engineers in the field as well.
Absolutely. So Ana Luisa, do you have a particular memory from one of these outreach events, something that was really striking or meaningful for you?
Well, I gave a talk it was a symposium that I gave a talk at.
Ooh.
And it was an event at the Physics and Astronomy department. And I went up and I gave this talk about my path in engineering and how I got to where I am and the work that I do. And at the end, I had this student come to me. She was a high school student who couldn't believe that she was meeting a professor, and that I was a female professor was even more exciting to her. She was just so excited. It was almost like meeting a movie star, how she was reacting, right? And I was like, wow, I never thought that I could have this kind of effect on someone. Mm-hmm. And during that same event, one parent came to talk to me to tell me how inspiring everything was and how thrilled she was that I was willing to dedicate my time to talk about my path and encourage others to follow in a similar path. So that was really rewarding.
Certainly. Well, congratulations on your recent awards that you mentioned, as well as we really appreciate you getting out there and sharing this message with young people who are interested in pursuing engineering or perhaps didn't realize they might be interested in pursuing engineering. I think that is phenomenal. So we talked about this aspect of the career that's really great, these opportunities that you get to reach out, to talk to the public, to work with young and aspiring scientists and engineers. But I think one of the other things that's great about your career is the opportunities that you get to travel. So I'd love to talk about those as well. So do you have a favorite place that your work has taken you?
So most of my travel is related to conferences. Going to different events and speaking about our research, I think is very important. I've been to various places in Europe and South and North America. And my favorite trip was in 2018. I went to the IEEE Biorobotics and Biomechatronics Conference, or Biorob, in the Netherlands, in Enschede, the University of Twente. And this was a great conference to begin with because it was a group of scientists and engineers that have been working in the field of surgical, medical, rehabilitation robotics for many years. So it was just a great conference to have been to. But what made it really memorable is that I took my family with me. So my husband was also participating at the conference, which made it easy. So we brought our kids. They were 13 and almost 16 at the time. So they were old enough that they could sort of hang out on their own. But what we did is that we took some time afterwards and we went into Belgium and back into the Netherlands. So we did a lot of different museums. We went to a lot of different little towns, tried different foods that we wouldn't get in North America. And I think it was just really cool to hang out with them. Traveling with kids, it just gives you a whole different perspective because things that you wouldn't notice, they notice, right? And they notice and they tell you and they're like, oh, yeah, you're right. That's really cool. So it was just really great to appreciate things differently. For example, we went to the Design Museum in Ghent, and that was cool on its own. But then having my kids making comments about the different things and asking questions, I think we laughed the entire time we were there. It was just so entertaining. But it was overall a really good experience joining the family together in that type of event.
So in terms of the sites that you saw, you mentioned this museum in Ghent. Were there any other things that you saw that you were like, wow, listeners, you need to check this out too?
Oh, we went to the Graverstein Castle, which was just an amazing structure. There were sections of it that were in pretty rough shape, but just being able to see the history of the whole castle in the walls and in the floors, it was just really amazing. And then back in the Netherlands, we went to the Mauritius Museum. The art in there was really impressive, and those were great places to see.
Well, it sounds like a phenomenal trip, and it sounds like you were able to make some great memories with your family there. And you also mentioned that the conference was a wonderful experience as well. And I think as a scientist, being able to travel all over the world to meet and work with different researchers in engineering and science is a great opportunity. And it kind of shows people that there's these international bridges and that not all scientists have the same personality that's portrayed in the media, the stoic, always serious, always critical, and always working in the lab sort of person. And I think this is an important element to highlight as well, because so many of the people that I worked with in science and engineering are these amazing, creative, and oftentimes very funny people. So I love talking about the humorous memories that you've shared or just the quirky traditions that you experience in different labs. So, Ana Luisa, do you have an example of one of these experiences of your own that you can share?
It's a funny science memory that I have to share with you. I was probably about a year into my master's degree at UBC when a photo/video session was going to take place featuring this new robot that had been designed in the lab that was supposed to move an ultrasound probe along the skin of a person automatically. So I was asked to act as the patient in these photos and videos. So I was going to be lying on a table and the robot would be running an ultrasound probe around my neck area. So trying to get an image of my carotid artery. So I was doing this and the robot was positioned such that it was gently touching my neck. It was all a very controlled environment and there was absolutely no chance of anything possibly happening. But my supervisor was so nervous. He kept asking me, "Are you okay? Is that too much pressure? Are you feeling dizzy? Are you okay?" So it was sort of sweet overall. But the really funny thing is that about 15 years later, I would still attend presentations where someone was giving some kind of overview of medical robotics. And true enough, the picture of me with the robot on my neck would appear.
You're famous.
Yeah, those photos got a lot of mileage. I'm sure they had no idea who the person was, but the robot was very famous after that. In my current lab, we have lots of really fun traditions. We do game nights. We participate in races. We do escape rooms. And we do all sorts of different little challenges. Like right now on Monday, we're about to start a sit wall challenge. So we have to sit against the wall and we have to increase the time. I think we start at 30 seconds and we go all the way to 5 minutes.
Oh, wow.
And we have a little tally on the wall where we keep track of who's done what. So it's just sort of different competitions to keep people active. And this thought that part of the philosophy of the lab is lifelong mobility. We encourage a lot of exercise. So we do little challenges like that, which is fun.
I love it. So are you typically one of the champions of these challenges?
No, I usually complete them, but there's some really amazing athletes in my lab, so I can't compete with them.
Oh, that is so cool. And you mentioned game nights as well. Do you have a favorite game that you like to play with the lab?
Well, yes, we play a lot of games that quite a few are our favorite, but I think my personal favorite is one called Pandemic, which is actually very relevant these days. Mm-hmm. So it's a game that you play as a team. Each person is not competing against the others. We all play together to win or lose the game. And it's about containing the spread of a particular disease. So there's different cards that tell you what disease is, how infectious it is, and all the different things. And the way you play, you start creating research, you start creating vaccines, you start controlling it in different ways. So at the end, you either control the pandemic or the whole world is dead. It's sort of a fun game. And I really like the fact that it's a team game. So it encourages people to collaborate, which is good.
I love it. Well, that sounds like a lot of fun. And I'm so glad to hear that you're able to incorporate these elements of fun and camaraderie in your laboratory, because I think that's really important for having that supportive, encouraging, creative environment for research as well. And I think you and the team there are really answering some great, important questions with the work that you're doing. But oftentimes things like funding, staff, technology, feasibility, gravity, whatever the case may be, tend to limit what you can do. So Ana Luisa, if we gave you everything, all of the resources you could dream of, all of the barriers are gone, what is the one question you would most want to answer?
I would like to find out what is the real relationship between the human and the wearable robot and how one affects the other. So when you have a machine that is attached to the human body, there's a lot of unexpected things that can happen. The human is going to start behaving differently because of the presence of this wearable robot, which in turn is going to behave differently because of the changing conditions of the human body. So there's a lot of work that can be done in incorporating artificial intelligence to learn from how the signals are changing and informing how the robot needs to behave differently under the different changing conditions. But we would definitely need a lot of funding to create quite a few devices that we can then run extensive trials and collect large amounts of data, and lots of people to develop software in order to get this done.
Certainly. So would you most be interested in tackling kind of the hand area, or are there other areas of robotics that you're interested in as well?
So most of the work we do is in upper body, upper limb mobility issues. So that can be anything from the fingers to the shoulders or neck area. My focus has always been on upper body because I feel that lower body, first of all, there's a lot of people working in the area already, but also the dynamics are simpler. What will you do with your feet, right? Like, or with your legs? You walk, you sit, you stand, you run, you go upstairs, you go downstairs. With the upper body, we do so many different things that I think the need for this artificial intelligence is a lot more prevalent. So that's why I've sort of been working in the upper body mostly.
Certainly. I think that fine motor control is definitely more emphasized in the upper body. So very cool. Well, it's been great to dream big with you and talk about some of these big projects you'd love to tackle someday. And we've talked about a lot of elements of your life and of your career, Ana Luisa. And I would love to end our conversation with talking about advice that me and our listeners can apply to our own lives in science. So do you have a particular piece of advice that was really helpful for you that you can pass on to us today?
Yes. And unfortunately, I can't remember who gave me this advice, but it was the advice to go with your gut, which in a way I've interpreted as not listening to other people's advice, which is sort of contradictory when you're going to ask me to give someone advice. But it's important to be informed and to hear what other people have to say. But ultimately, it's up to you to make that final decision. And it's very easy to listen to your body, and it's going to tell you whether it's the right thing to do or not. It's something that I've applied to many aspects of life, what to do about my career, what to do about my kids, what to do about my health. There's always that little voice inside me that tells me what I should do. And it honestly always seems to work. And an example that I can think of is when my kids were small, they're a baby, you know, they're sick, and you're like, should I go to the doctor? Should I not go to the doctor? And I ask my husband, right? Or I ask my parents or my parents-in-law. And ultimately, it was just really, I think I need to take this kid to the doctor. And it was always right. Like listening to that internal voice was always the right thing. Also, like making different decisions about my career path. Definitely I'd listened to my gut, and it's always worked.
Well, excellent advice. Listeners, you should take this piece of advice. And Ana Luisa, is there any other last piece of advice or a last message of inspiration that you want to leave us all with today?
So the way I ended up where I am now was by finding something that I felt very passionate about. It's not like I went searching for it. I sort of paid attention about what was happening in my environment, my knowledge. And then when I realized that I wanted to help those living with mobility problems, in part because of my own injuries, but in part of seeing just people around me, like the number of people that suffer from some kind of musculoskeletal issue, then it became my goal to figure out how to apply my knowledge and my training, which was engineering design, to helping solve this problem. So it really helped me to find my own path. And I believe a lot of people can do the same, because success will come naturally if you feel passionate about what you want to do. And then just keeping in mind that ultimately today is the best day of your life, because today is when you can actually make a difference.
Oh, I like that. Wonderful message to leave me and our listeners today. And Luisa, if our listeners are inspired and they want to learn more about you and the phenomenal work that you're doing, what is the best way for them to do so?
So they can check out my website and my lab website at Western University. And the easiest way is to search for it with my name, or my lab name is the Wearable Biomechatronics Laboratory at Western. And of course, you can always send me an email. It's atrejos@uwo.ca. But I do get a lot of emails and I don't always get to all of them. I do try to respond to every email, but that sometimes means that I forward it to one of my students or one of my postdocs so that they can answer the request better.
Certainly. Well, I can totally commiserate with the email situation. My inbox can be a scary place sometimes. So
yes, absolutely.
Listeners, definitely check out that website. Get in touch with Ana Luisa if you have any questions. And Ana Luisa, it's been such a pleasure to chat with you on the show today. Thank you so much for spending time with us.
Thank you so much for having me.
Well, it was a joy to learn more about you and the work that you do. And listeners, always great to have you here with us. We'll see you next time on another episode of People Behind the Science.